All right, so the last time I finished with you, I was talking about how there was something pretty cool, and I really do believe it is. When you look at oxygen, which has 8 electrons, its electron configuration, 1s2, 2s2, 2p6, oops, excuse me, 2p4, that's oxygen. Sulfur, with 16 electrons, was 1s2, 2s2, 2p6, 3s2, 3p4. And what's, I think, interesting to notice is the ending. Notice 2p4 and 3p4 respectively for oxygen and sulfur. Let's take a look at our periodic table here, okay, at where these are located. Notice that oxygen is right here. That's not a great circle. Let's go ahead and try that again. Oxygen is right here, and sulfur is right below it. Recall when we talked about the blocks of the periodic table. We said helium is often viewed as being over here on the left side when we talk about blocks. But we mentioned that the S block was on this side, the left side right here. The P block was on this left side, right side. The D block is in the middle, and the F block is on the bottom. Notice the endings of oxygen. 2p4. Well, here's oxygen. Notice the ending of sulfur. 3p4. You also remember, hopefully, that, well, and you can see the 4 as the superscript. Notice that it's the 1, 2, 3, 4th over. Both oxygen and sulfur are 4th over. I bet that you could guess what selenium would end with. Its electron configuration would end 4p4. All right? Now, how do I know this is a 2p and what we mean by that? Well, do you recall that the S's started counting at 1? So the S's started counting at 1s over here. So that's this row right here. The P's, there was no 1p. So this is the 2p row. The whole row right here is the 2p. So if I clean this up real quick here, just so you can kind of see it a little bit better. All right, and we know we've got these here, and we'll take a look at that in a second. But if the S's start at 1, so this is the 1s, which of course would include helium. The P's start at 2. This would be the 2p row. Meaning boron should end 2p1. Oxygen 2p4, because it's the 1, 2, 3, 4th one over. This family, the noble gases, would end something p6. Doesn't it make sense that there's 1, 2, 3, 4, 5, 6 in the P? Okay, so our whole periodic table can be looked at with grids. We got these blocks. We've got these grid lines across, 1s, 2s, etc. And then the amount across is our exponents. Okay, so we can grid up our entire periodic table and therefore know what an electron configuration will be for each element, or take a look at the comparison of orbital diagrams. Let me take a look here. This is a nice website. This is, as you can see on the URL up here, webelements.com. I like this website, webelements.com. But you can see here basically the colors. Now, and notice how helium is kind of bluish yellow. They kind of made it bluish yellow a little bit because yes, it's yellow. It acts like a noble gas, but for our purposes in terms of blocks, it can fit over here. So these blue ones are your S block. The yellow ones over here are your P block. So this is your S block. These are your D, and these are your F block. Now, what I like about this one is there's a little bit of room to write on it as well. S's start at 1, so this is the 1s row. This would be the 2s, 3s, 4s, 5s, 6s, 7s. Obviously, any of the ones in the first column would end S1. 1s1 would be hydrogen. 5s1 would be rubidium. 3s1 would be sodium. Okay? Now the P's start counting at 2. There is no 1p. So this is the 2p row. This would be 3p, 4p, 5p, 6p, and then these are some new elements, 7p. Okay? Those are, and on my periodic table on the wall in class, I don't have the 7p, but that's all it would be. The D's would start counting at 3. So there is no 1D, there is no 2D, it's only the 3D. So 3D, 4D, 5D, and 6D. All right. And notice on this one, I like this one better than maybe the one that's in my room or the one you have because it has that little, you know, the little dashed line. Notice they did put 71 and 103 up in the D block. That's where I want them. That's where they belong. Okay. The F starts counting at 4. There is no 1F, 2F, 3F. F's start at 4. Okay. And there's your rows. Obviously, the 1, 2, 3, up to 10. Why do I know it's 10 without counting fast? Because I know that a D set of orbitals has 5 orbitals. Each orbital can have 2 electrons. That means a maximum of 10. That's why it's 10 wide. Okay? If we were talking about iron, iron's electron configuration would end 3d6 because it's the 6th one over. Okay? Now we do need to know the order of all of these, and the way that we can do this, rather than any kind of memorization, the way I like to remember is just to count. If I said count from 1 to 112 right now, pretty sure all of you could do that. In terms of remembering the order, you need to remember this. I remember where are the blocks? S, P, D, F. So I've done that, and I have my S, P, D, F. The next thing I remember, what do they start counting? S's are at 1, P's are at 2, D's are at 3, and F's are at 4. And so, I think I'm moving around. So now that I have how many, then I can just count. It would go 1S, 2S, 2P, 3S, taking care of the ones I'm kind of going, 3P, 4S, then 3D. The reason 4S has a lower energy than 3D, it's a little bit complicated, but basically, if you remember kind of looking at some of those orbitals, the way that they're funky in between axes, X, Y, and Z axes, it makes it a little bit more complex, which therefore it has a higher energy than the 4S. So you can see the overlap. You don't have to memorize the overlap, just look, 4S and then 3D. After 3D comes the 4P. After number 36, right, we're over here, we come to 37, 5S, then 4D, then 5P, then 6S, down here, 4F, then back up here, 5D, 6P, 7S, down here, 5F, 6D. So those are the order of our orbitals.